absolute and conditional convergence. Okay, let me write it down. We'll look at the topic of absolute and conditional convergence. Now what it is about, see, you have a series in which all the terms are not positive. Okay, you have a series in which all terms are not positive. Okay, and you are given that this series is a convergent series. Okay, this is given to you. Now you make all the terms positive in this series. Okay, for example, you have a series like u1 plus u2 minus u3 plus u4 minus u5 minus u6 plus u7 and so on up to infinity. Now in this is not an alternating series either. You have random positioning of plus and minus sign in this series. So this, all the terms are not positive, but this is given to you as a convergent series. Now if you make all the terms of this series positive, that is, if you write it like this, u1 plus u2 plus u3 plus u4 plus u5 plus u6 plus u7, so now all the terms have been made positive, and still this series remains convergent. So if this is the case, then the condition is known as absolute convergence. That is, when they are not positive, or all are not positive, and when they are made all positive, the convergence condition stays. So it is known to be absolutely convergent. Okay, and if this thing becomes divergent, then this condition is known as conditional convergence. That is, it was convergent only in a given condition, otherwise not. Let's take an example for this kind of convergence. Let us look at a series that is 1 minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square and so on. Now this is an alternating series. Okay, let me check the convergence of this alternating series by Leibniz rule. So if you find out un will be 1 by n square. Okay, and if you find out un plus 1, you would get 1 plus n whole square. Let me find out this ratio. This would clearly get me a value which is less than 1. So first condition is satisfied, and if I check the second condition, this is also true. This means this series is a convergent series as per Leibniz rule, because it is an alternating series. Now if I make all the terms positive, if I make it like this, so in this all the terms have become positive now. Now whether it is convergent or not, let's check it. Just look at it. This is nothing but a p series. A p series is where n starts from 1 and goes up to infinity, 1 by n to power p. So the convergence or divergence depends upon the value of p. Okay, here the value of p is 2, which is greater than 1, which means that this series is also convergent. So this means this is an absolutely convergent series. So in both the cases the series remains to be convergent. Okay, so this is how we look at absolute and conditional convergence. Okay, now this was all about the topic of infinite series. I hope you understood most of them. So till next video lecture or next chapter, have a good day. Bye bye. Hi and welcome to this video on the topic of infinite series. We will be continuing this video lecture series from the last topic, that was on comparison test. In this we will look at the D'Alembert's ratio test and some other tests like Rabi's test, logarithmic test, and so on. So let us start with this D'Alembert's ratio test. In this, first of all, let us define this test. Okay, now it is valid for a positive series, that is, in which all the terms are positive. So let sigma un is a positive infinite series. Then we need to find out the ratio of this term, that is un by un plus 1, and you need to find the limit for this ratio as n tends to infinity. Let us say this limit comes out to be lambda. Now the convergence or divergence of the series, that was sigma un, depends upon the value of lambda. Now you need to remember this, that based upon lambda your series will be convergent or divergent as per the D'Alembert's ratio test. Now your series will be convergent if lambda is greater than 1. Second, your series will be divergent if lambda is less than 1. Now there is a peculiar case that happens in this test, that at lambda is equal to 1 this test fails. That is, when you get the value of lambda as 1, the test is inconclusive, that is, it cannot tell you whether this given series is a convergent series or a divergent series. Okay. Let us look at an example. Let us take a series which is given as like this, where n starts from 1 and goes up to infinity, n factorial upon n to power n. Okay, so this is a series which is given to you, and you need to tell me, or we need to find out whether the series is convergent or divergent. Now let's start by finding out un. This is your un basically. So the un is given to be n factorial divided by n to power n, and then I need to find out un plus 1, which is simply found out by replacing n by n plus 1. So you will have n plus 1 factorial divided by n plus 1 to power n plus 1. Now let us find out the ratio of un by un plus 1. Un was n factorial by n to power n, and this would come to be the reciprocal, so this is the case. Okay, now let us simplify it. You would get n factorial into n plus 1 into power n into n plus 1 to power 1, that is simple exponential law, divided by n to power n into n plus 1 into n factorial. Now n factorial gone, n plus 1 gone. So after manipulation you are left with n plus 1 by n to power n. Okay, now let us simplify it a little bit further. You will get 1 plus 1 by n to power n. So this is the value that you get. Now I need to find out the limit. The limit for this will be E. The limit for this will be E as n approaches infinity. Now E means exponent value. Now exponent is always greater than 1. If you look at the previous slide, the series will be convergent if the value of lambda, that is the limit of the ratio, is greater than 1. And in this question that we have, the limit is coming out to be greater than 1. This implies that the given series, that is sigma un, the series is convergent. Okay, so this is how you find out whether a series is convergent or not. Okay. Hi and welcome to this video lecture on the topic of heat transfer, in which we would look at some basic concepts before you actually begin to study the subject and start going in deep on various concepts. Now, from the study of thermodynamics, we have learned that energy can be transferred by interaction of a system with its surroundings. Okay, so if you have a system, so you can transfer the energy to its surroundings, or it can also happen vice versa, that is the surroundings or the energy can be transferred from surroundings to the system. It can happen either ways. Now these interactions are called work and heat. These are the two ways in which a system and surrounding interact with each other in terms of energy transfer with each other. Now, however, thermodynamics deals with the end states of the process, during which an interaction occurs and provides no information concerning the nature of the interaction or the time in which that interaction is occurring. For example, you have a bar, you have a rod, steel rod, and you are heating it at this end. So the temperature at this end, let us say, is T1, and the temperature at this end is, let us say, T2. So with the help of thermodynamics, you can only come to know the end states of this heat transfer process or this heating process. Okay, you can come to know about temperature T1 and you can come to know about temperature T2, and you can also calculate the amount of heat, the quantity of heat that is being transferred from this point to this point, the total amount. Okay, so this is what we can find out with the help of thermodynamics. Now, what is thermodynamics not providing us is the time in which this heat is flowing from point A to point B. For example, by thermodynamics we were able to find out the total amount, that was 100 kilojoules. Okay, but 100 kilojoules from point A to point B in how much time? I don't know. Okay, so for that we come to the subject of heat transfer. Okay, and also with the help of heat transfer we can come to know about the nature of this interaction. We'll soon come to know what do we mean by the nature here. Okay, the nature of interaction can be sought from the topic of heat transfer. And there is one more thing which can be found out with the help of the subject of heat transfer, is that apart from knowing the end conditions, we can also find out any condition on any intermediate point between points A and B. So you can also find out condition of the system or condition between two end states at any intermediate section or at any intermediate position of the system. Okay, so these are the benefits when we analyze a particular heat interaction or energy interaction problem with the help of the subject of heat transfer. Okay, now The objective of this subject is that we are going to analyze the various uh, heat interaction processes as different modes of heat transfer. Okay, so that would come under the nature of interaction. So now we would be studying about the modes of heat transfer. The writing is going off a bit. That is modes of heat transfer. What are these modes? We'll soon come to know about that. Okay, and in this video we would be stressing upon some important questions, and those important questions are: first, what is heat transfer? So we would throw some light upon what do we understand or what do we mean by this term heat transfer. Okay, then we would throw some light upon how is this heat transfer. Okay, how is the heat transferred? Now when we talk about how of heat transfer, we would be studying about the various modes of heat transfer. Okay, so now you have an idea what we understand by modes. Okay, and the next point that we would hit upon is why heat transfer is important. Now, this is not a very important question to hit upon if you are preparing for some competitive exams, but yes, it is definitely an important question if you want to actually elevate the level of knowledge for this particular subject. Okay, hello and welcome to this first video lecture on the topic of refrigeration and air conditioning. In this first video lecture we would look at some basic topics regarding the subject. Now let us start by defining what is refrigeration. Now if we define it, well, refrigeration is a process of removing heat from a substance under controlled conditions. Now what are those controlled conditions we will look at in the subsequent video lectures. Now the basic process is that of removing heat. Okay, now if we talk about heat, this means we need to study heat also, or we need to have a knowledge about what heat is. Now heat is, as we all know, is an energy which flows from a body at high temperature towards a body at low temperature. Now this is the natural flow of the heat energy. Now what is happening in refrigeration is that the substance, let us take this as a refrigerator, and this is the body which we need to cool down. Now the outside temperature may be 35 degrees Celsius, okay, the ambient temperature, but this substance is let us say minus 2 degrees Celsius. This means we are continuously extracting heat from this body and throwing it outside, that is to an atmosphere of 35 degrees Celsius. This means in refrigeration the heat flow is from low temperature to high temperature. Now this is an unnatural flow of heat energy, and this happens if we provide some work input. Now how do we do that? We will look at it in the subsequent slides. So this means heat naturally flows from high temperature to a low temperature, but in refrigeration we are making heat flow from low temperature to a high temperature surrounding by giving in some work input. Now before we move ahead, let us look at the next slide. Okay, what you can see here is a plot between temperature and heat. So you keep on giving heat, you have a sample of ice at minus 10 degrees Celsius, Okay, you start heating this. When you start heating it, the temperature of the body increases. Okay, so what happens, as you can see, we will mark it with a black marker. Okay, so when you are at minus 10 degrees Celsius ice and you start giving heat, this is a continuous process, the temperature starts to rise. It keeps on increasing and it reaches 0 degrees Celsius ice. So still the phase is ice, the phase has not changed. What has changed? The temperature value. The temperature has increased from minus 10 degrees Celsius to 0 degrees Celsius. Now again, you are not stopping the heat, you are still giving the heat. Now something strange happens. The temperature does not change, it stays at 0 degrees Celsius, as you can see here. But now the phase, it changes from ice and it becomes water. Now there is some melting which has taken place. Still you keep on giving the heat, you are still very persistent. Now what happens? The temperature starts to increase again. Now 0 degrees Celsius water has now become water at 100 degrees Celsius. Now as you can see, the state is same, but the temperature has again increased. Now at this point, as you keep on giving the heat, the temperature change stops. There is no change in the temperature, but there is a change in the phase. Now looking at this graph, this means we need to have a very important concept to understand here, is that when you give heat, sometimes the temperature changes and sometimes the state changes or the phase changes. Now what are these two kinds of heat actually? So if you look at this heat, in this heat, what is happening? There is no change of phase, but there is some temperature change. This kind of heat is called sensible heat. Okay, now if you look at the second one, in this there is no temperature change, but there is some state change. This kind of heat is called latent heat. Okay, this means in sensible heat will have some temperature change, but the phase will remain the same, and in latent heat there will be no temperature change with the change of phase. And next, this is also some amount of sensible heat, and again this is the latent heat. Now summarizing it in the next slide is that sensible heat, you have some temperature change, but you do not have any phase change. In latent heat, you do not have any temperature change, but you have a certain amount of, or you have a certain phase change. Now mathematically putting it, sensible heat can be given as mc delta T and latent heat can be given as ml. Okay, where C is the specific heat capacity of the substance. Okay, and L is the specific latent heat. The units for specific heat capacity is kilojoule per kg Kelvin, and the units for specific latent heat would be kilojoule per kg. Okay, some important values for you to remember is that specific heat capacity for water is 4.2 kilojoule per kg Kelvin, and latent heat capacity of ice is 335 kilojoule per kg. You need to remember these two values. These values will be used very often.